Hello friends, welcome back to Edupedia Word Videos, your destination to free education. This video is the continuation of the topic Applications of Trigonometry. In fact, it's the second part of this topic. The question says a boy which is 1.5 meter tall. Say we have a boy, it is 1.5 meter tall, is standing at some distance from a 30 meter tall building. We have a building which is 30 meter tall, and this boy is standing at some distance, say x meters from this tall building. The angle of elevation from his eyes to the top of building increases from 30 degree to 60 degree as he walks towards the building. Now these are the eyes of this observer, this boy, and he's walking towards the building. Say these are two instances of his walking. The angle of elevation from his eyes to the top of this building increases from 30 degree to 60 degree. So at two instances the angle is 30 degree and 60 degree over here. To find part is find distance he walked towards the building. So we have to find this distance, let us say denoted by y. So let us assume that again the building is perpendicular as well as the boy's position are perpendicular to the base, the ground. So let us rename this triangle as A, B, C, D, and correspondingly these points as B dash, C dash, and D dash. Now we have to find the distance DC or y. So since the building is 30 meters tall, and you can, if we draw a line parallel from the eyes of the boys that are parallel to the ground, this distance becomes 1.5 meter, the height of the boy. So the distance AB, the length, the height AB equals AB dash minus BB dash, that is 30 minus 1.5 meters or 28.5 meters. Now let us resolve the question by two triangles. We have assumed BC as, this B dash D dash as x meters and CD as y meters. Now since the line BD parallel B dash D dash, so BD equals B dash D dash, because the position of boy is perpendicular to the ground, as well as BB dash is also perpendicular to the ground. So BD and BD dash, B dash D dash, both are x meters. Now in right triangle, let us say ABD, the major triangle including the angle 30 degree, we have, friends, if we look, both the triangles formed, AB is common to both of them, so we will be using AB in our advantage. Thus tangent of the angle D, that is tangent 30 degree in right angle triangle ABD, is AB over BD, implies that now tangent 30 degree is 1 by under root 3, which is equal to AB over BD, or we can say BD is AB under root 3. Similarly, in right triangle ABC, that is this triangle, we have tangent 60 degree. We are using tangent because we have AB common in both the triangles, and it can be advantaged by taking tangent of angle. So tangent 60 degree is AB over BC, implies that here BC is AB over tangent 60. Now friends, tangent 60 degree is under root 3, so BC becomes AB over under root 3. Now we have to find out CD. What is CD? CD is this particular distance, so it is nothing but BD minus CB or BC. So CD equals AB under root 3 minus AB by under root 3. Now what is AB? The value of AB is over here. We have calculated it to be as 28.5 meters. So taking AB common, we have under root 3 minus 1 by under root 3, which gives us 28.5, and in the brackets we can take LCM as under root 3, so under root 3 into under root 3 minus 1, which is 28.5. Under root 3 into under root 3 is under root 3 square minus 1 over under root 3. So it is 28.5, 3 minus 1, which is 2 over under root 3. Now since it is an absurd form, rationalizing this under root 3, the denominator part, we will simply be multiplying and dividing by under root 3. So it will give us 28.5 into 2 into under root 3 over 3. Now 28.5 into 2 is 57, This 57 is the 19th multiple of 3. So CD, the required distance, the required result is 19 under root 3 meters. Thus, if the 1.5 meter tall boy, the angle of elevation from his eyes has changed from 30 degree to 60 degree while moving in front of this particular building, then the distance moved by him will be 19 under root 3 meters. Let us have another question. The question says two poles are of equal heights. Let us have two poles, say A, B and P, Q. Now they are standing opposite to each other on either side of road, which is 120 meter wide. They are standing, see, if it is a road, then they are standing opposite to each other, which we have already mentioned, on either side of the road, and the distance, the road is 120 meters wide. So since they are standing opposite and this is the road, this length PQ will be 120 meters wide. From a point between them on the road, it is a point between them on the road, angle of elevation of top of poles are 60 degree and 30 degree respectively. Let us assume that PQ is the first pole, its angle of elevation is 60 degree, whereas for AB the angle of elevation, say, it is assumed as 30 degree. Find height of poles and distance of point from the poles. Now we have to find out height of poles, that is AB equals BPQ, and unknown, which is an unknown quantity, as well as distance of point from poles. Say this is the point of interest, say O. So we have to find distance of this point. We have to find distance of this point from the poles. Say OQ is this distance from the pole 1, whereas similar the pole of same height, pole 2, the distance from this point is OB. So we have to find out AB, PQ, OQ and OB. So let us assume, since we are given whole of the length of this road, the wideness of this road, let us assume that this distance BO is Y and this distance OQ is X meters. That is, assuming BO equals Y meters and OQ equals X meters. Now friends, clearly BO plus OQ is 120 meters because it is nothing but BQ. Further assume that AB equals PQ, which is already given the height of two poles, that they are equal. Say it is H meters. Both are H meters tall, H meters high. So in right triangle ABO, right angled at B, again we have assumed that poles are vertically erected that is, they are perpendicular to the ground, the angle of elevation is 30 degree. So since what advantage we have in this question, we have AB equal to PQ, so we will be using the two right angle triangles and will be utilizing this advantage. How can we do that? We have to incur this height in this triangle and this height in this triangle, as well as this distance which we have to find out. So again we need tangent of the angle. So in right angle triangle ABO, tangent of angle, here tangent is 30 degree, sorry, angle is 30 degree. So tangent will be perpendicular over base, that is h meters, or AB over base, which is y. Similarly in right triangle PQO, right angled at Q, we have tangent of 60 degree, because 60 degree is the angle involved, as h over x. So from the two given or the two formed equations, we have h equals here y into tangent 30 degree, whereas here we have h equals x into tangent 60 degree. Now from first and second we have y tangent 30 degree equals x tangent 60 degree. Now tangent of 30 degree is 1 by under root 3 and tangent of 60 degree is under root 3. So we have y over under root 3, y into 1 by under root 3 is x into under root 3. That is y, just rearranging the terms, into under root 3, or simply y equals 3x, thrice of x. But we also have BO plus OQ, where BO was y and OQ was x, as 120 meters over here. So using this equation hash and putting equation third in hash, we have x plus y as 120 meters, that is y here is 3x equals 120 meters, or simply 4x is 120 meters, or we can say x is 120 over 4 meters, which means x is 30 meters. Now y is 3 times x, so it will be 3 into 30 meters, that is 90 meters. Now what is h? H is y tangent 30 degree. So h is y, which is 90, into tangent 30, which is 1 over under root 3, that is 90 by under root 3. Now rationalizing the denominator, because it is not a proper form, the proper fraction, just multiply and divide by under root 3, we have 90 under root 3 over 3, or simply this 3 cancels 90, because 90 is the 30th factor of 3, 30th multiple of 3, so we have h equals 30 under root 3 meter. So the height of the two poles is 30 under root 3 meters, which we have calculated here. OQ was x, and x is 30 meters. So OQ is 30 meters, we have calculated over here. Similarly, OB is 90 meters. So this was the two-pole question. Let us have a last question of this video. The question says angle of elevation of top of building from foot of a tower. We have a building and we have a tower. Now, according to the given question, in general, friends, tower is more tall than a building, so we are using the longer length as tower, but there can be exceptions. So the angle of elevation is given from foot of the tower to the top of the building as 30 degree. Say this is the ground, the base connecting the two verticals, building and the tower, and the angle of elevation of top of the tower from foot of the building is 60 degree. Moreover, these angles also convey that tower is taller than building because this angle is more. See, this is 30 degree and this is 60 degree. 60 degree will be covering more height for the same vertical plane. Now the question says if tower is 60 meter long, find the height of the building. Let us denote this tower by PQ and the building, the length of height of the building by AB. So now we have to find out height of the building. It is to find AB, and we are given PQ as 60 meters. So the solution here goes. Here we have the advantage of the common thing, that is base of the two triangles. This is the first triangle, whereas this is the second triangle. So we'll be incurring the base, as well as we are given height in this triangle. So base and height are again related with tangent. Similarly, in this triangle we have to find out this height, and we have the base common to both triangles. So again base and height are involved, which is the part of the tangent ratio of the given angle. So firstly, in right triangle PQB, right angled at Q, tangent of 60 degree, because the angle of elevation is 60 degree, we have PQ over BQ as tangent 60 degree. Similarly, in right triangle ABQ, right angled at B, this triangle, we have tangent 30 degree because angle of elevation is 30 degree. Tangent 30 degree is perpendicular over base, that is AB over BQ. Now from the first part, BQ is PQ over tangent 60 degree, whereas from the second part, BQ is AB over tangent 30 degree. So from first and second, comparing first and second, we have PQ over tangent 60 degree equals AB over tangent 30 degree. which gives us, now PQ is given as 60 meter and we have to find out AB. So 60 over tangent 60. Tangent 60, my dear friends, is under root 3. By proper, substituting the values over and over again, you will get used to these trigonometric ratios. Moreover, these trigonometric ratios are, very easy to remember, and with practice, I assure you that you will never forget these ratios. So tangent 30 degree is 1 by root 3. We have AB over 1 by root 3. We have to find out AB, so we'll be giving solitude to AB, that is 60 over under root 3. Bringing this 1 by root 3 in this side, it becomes the multiple because here it was at dividing position. So we have AB as 60 over under root 3 into 1 into under root 3. So it will be under root 3 into under root 3, that is 3. So AB comes out to be 20 meters, that is height of the given building in the question is 20 meters. So friends, these were 3 questions on trigonometric ratios. In the next video, we'll be having some more practical applications of trigonometric ratios. Thanks friends for watching this video.